Welcome back. So in this video we will see a solution to the vertical displacement problem where we will use Python named constants. So remember, we are trying to solve the vertical displacement problem for an object that is thrown vertically at some initial speed and some initial position after t seconds, and that's given by the following formula. So to calculate the position of an object after t seconds is given by the formula y equal y0 plus v0 t minus half gt squared. And in this formula, y0 is the initial position of the object, and then v0 is the initial velocity of the object, and t is the time after which we want to find y. So want to find y. So basically after t seconds we want to find the y, or the vertical height of the object that is thrown at an initial position y0 and velocity v0. And in this formula, g is a constant, which is the acceleration due to gravity, and this constant is approximately equal to 9.80665. So if you remember, the question was, what is the input and what is the output of this problem? So the input to this problem is three quantities, and these are the y0, v0 and t. So these are our inputs. Now note that the value t appears twice in this formula, but this is the same t, so it's the same value or the same input. The only difference, the only thing is that we actually using it twice in this formula. And the output to this problem is the position after t seconds. So that's the y value, or this value in here to the left hand side of this equation. And in general, anything that is to the right hand side of the equation is an input, and anything to the left hand side is an output. The only exception here is this g value. So this g here, it's not an input. So remember, g is a constant. So this is not an input to our problem. This is a constant, which is a given, and it's given by this value. Now, in the field of physics, it's always a good idea to have an illustration that help you understand the problem that you're trying to solve. And here is an illustration for our vertical displacement problem. Now, let us assume that we are throwing a ball into the air at an initial velocity. So the initial velocity of the ball, or the initial velocity of this ball, is v0, which is, let's say, equivalent to 35. So the y-axis represents basically the height at which the height of the object, so how far up the object reaches. We don't care actually about the position in the x-axis, because we are not dealing with the horizontal displacements, we are only dealing with vertical displacements. So that's displacement along the y-axis. And this point here is basically represents height 0. So this is basically 0 height. So we start throwing this object at an initial velocity of 35, and also at initial position of 0. So the initial position of the ball, y0, is equal, in this case, is equal to 0. Now when we do that, after 1 second, this is going to be the position of the object, which is around 39 point something, and after 2 seconds is going to be close to, let's say, 59, and that's almost like 59.5, and after 3 seconds it's close to let's say 78.3, and after 4 seconds it reaches about 84, let's say 0.5, and then this would be the maximum height that is reached by this projectile, and after that it starts falling down. So after 5 seconds it's almost close to 61, and after 6 seconds it's close to that's about 42, and after 7 seconds it's near to the ground, so it is kind of close to 3 meters high, and before it reaches, or before the time becomes 8 seconds, it's actually going to hit the ground, so the height again is going to be 0. So what we want to do is that, given if the user gives us as an input 35, which is V0, and if the user gives us as an input Y0, and let's say the user gives us 0, and let's say that we want to find the position after, let's say, the 6th second. So if the input from the user is 6, the value we should get is 42, or should be close to 42. Now note, this are not real positions, so the actual output should be different from this. But this is basically to give you a hint of what we are trying to achieve. Now, for those who are interested in physics and who are interested into actual physical quantities, the height Y0 will be measured in meters, velocity will be measured in meters per second, and time will be measured in seconds, and the acceleration due to gravity is measured in meters per second squared. So let's see how we can code this problem in Python. So as we have done in the field perimeter problem, we will start by describing what our program is supposed to do. And we are still having the 3 main steps that we have described before, and these are getting input, doing computation, and displaying output. So our program is having 3 inputs, so there will be 3 inputs to our program, and these are, so the program is supposed to get as input Y0, which is the initial position, and also should get as input V0, and it also should get as input the time t. These are the 3 inputs that our program is supposed to get. It should also do a calculation, so calculate the vertical displacement, y, and the last thing we want to do is we want to display the results. So that's the 5 steps that our program is going to take, and that's basically our algorithm. Now, because we're going to be using a named constants, it's a good idea that you declare your constants at the top in the beginning. So remember, we need to declare a constant, which is the acceleration. So that's the acceleration due to gravity, and that's g. And because it is a constant, we will define it in capital case. So remember that when you define your constants, make them in capital case. So g is equal to 9.80665. So that's our constant. And let's get the first input. So the first input is y0. And because all our input is basically numerical data, and because it is these are physical quantities, so the input is all going to be in floats. So we'll need to convert all our input to floats. So the first input enter the spelling might not be correct, so enter the initial position. That's the first input. Second input, v0. Again, this is supposed to be a float. Enter the initial velocity. And the last input is basically basically the time t. Again, time is a continuous quantity, so that's why it's supposed to be also a float. So input, enter the time t, or enter the time. Okay, now what I want to do, I want to make sure that basically my input, or I just need to make sure that the input prompts are displayed nicely. So I'll just make sure that all the inputs are somewhat balanced, and that's by just inserting some spacers. So these dots are just simply spacers, so they're not, you could use spaces or you could use other characters, but I find the dot more appealing. The second thing we want to do is we want, now we have all the inputs from the user. Let's do the calculation, and the calculation is, as we said, you calculate the value of y, which is equivalent to y0 plus v0 times t. So that's v0 times t. Remember, star is multiplication, plus, minus. So that's minus 1/2. 1/2 is 0.5 times g times t, and t is raised to the power of 2. Now I don't need any brackets here because this is going to be the first operation that will be executed, and the multiplication has precedence, so that will be executed second, and then the whole thing here will be executed third, and then the plus, and then the minus. So that should be this calculation basically is semantically correct. And then the last thing I want to do, I want to display the results. Now, it's a good idea that when you're displaying results to the user, not only that you display the actual output, which is the y value, but you also display what has been inputted, and you try to put that into something that the user can understand. So for displaying the results, I will actually display some kind of a paragraph or some kind of a long sentence which explains exactly what is happening. And I'll start by just typing how I want my output to look like. So I will say that an object placed at y0 position, so meters. So I'm making an assumption that all my units are basically in ISO units, or international standard units. So I'm using meters for height, and thrown up. So that's thrown up at, and let's print a second line. So I don't want to be my output to be very long in one single line, so I'll break it out in multiple line. So this is an object that's placed at y0 meters and thrown up at velocity of v0 meters per second, will be at y meters, and it's going to be in y meters after t seconds. Okay, so what we are saying here, that an object which is placed at some initial height, and we are throwing that at some velocity. So I need to spell this correct. So that's velocity of v0, and it will be at y meters after t seconds. Now this is going to be printing only strings. Remember, I need to print the values of y, t, v0, and y0. If you remember from the discussion in the last lecture, that what you need to do, you need to separate the actual variable from the string by these commas. There is another nicer way in Python which you can actually insert the value of a variable within a string, and that is called formatted strings. And the way you can do that is you need to put an F before the first double quotation or before the first quotation. So you put an F there for formatted strings, and if you want to display the value of y0, you just put it between braces, and that's basically will print. So what will that do? It will take the y value and it will insert it inside the string. So whatever value you have at y0, it will be inserted here. Whatever value you have at v0, it will be inserted here. And whatever value for t, it will be inserted here. And whatever value for y, it will be inserted here. So this way we can see, or we can insert the values of these variables easily. Now let's save this thing and let's test drive it. So let me run it for the first time. So it's asking me for an initial position. So let's say that as an initial position I give it 0, and for the initial velocity, let's say it's 40 meters per second, and for the time, let's say after 2 seconds, I want to see where is the output. So this is the output that I get. I'm not really happy with it, so we'll modify it a little bit further. So we have an object that is placed at 0.0 meters and it's thrown up at a velocity of 40 meters per second will be at 60 meters high. But as you can see, I'm getting a very long number here. I would like to format this a little bit, so we'll deal with this long number here. And another thing I want to do, I want to just keep a space between my last prompt and the output. So what I will do, let me come back to the code here and I'll put a /n. So that's to give myself a space. I need to fix some quotations in here, so that's fixed. And to format the output, so this is the number, so I'm not liking how the output is coming out. So I just want to print the output in 2 decimals. So what I will be doing, I will give this thing a formatting, and what I want to do, so you add a colon, and whatever comes after the colon is basically the formatting of this number. So that's 0.2f. So print only 2 decimals after, for this floating point number. So 0.2 here means that only display 2 decimals. Now let's run this thing again. So 0 meters, 40 meters per second, and after 2 seconds, and now this is the output I'm getting. As you can see, if you compare this output with the previous output, it looks much nicer. So an object that's placed at 0.0 meters seconds and it's thrown up at a velocity of 40 meters per second, it will be at 60 meters after 2 seconds. And you can test drive this with more values, with different values, to see different results for the displacement of the object. So that's the solution for our vertical displacement problem. In the next video, we will look at more math operators. So we'll expand on our vocabulary of mathematical operators.